The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone and welcome. My name is Nathan, otherwise known as Old Man Builds. We have Papa Bale here with us. We also have his brother Chris from Convergence Emergence with us. Guys, how's it going?
Awesome, Nathan. How are you?
Doing great, man. How you doing, Chris?
I'm doing very good, thank you. Hanging in and looking forward to this conversation. Thanks. Good to be here.
Right on, guys. All right. Just checking in with everybody. He's coming on. My neighbor Dispatch over there, hanging out. Everybody's coming in hot.
Hey.
All right. This is going to be pretty cool, man. We got a lot of things to go over today, man. You got some awesome stuff on your pulse motor, man. You got the Utron. That's just totally cool. We were just talking backstage a little bit about reversing how you did all the electrical in your pulse motor, which is just fascinating in itself. So where do you want to start, man?
Oh, yeah. Well, let me see if I can flip this real quick. Yeah, I want to start by saying how awesome it is to be on your show. And I really appreciate the opportunity. Yeah, I've been into building the pulse motors for, I'd say, about 2.5 years now, and I kind of just fell into it. I started off by just making magnetic toroids, basically, large wooden discs, and I would glue little bar magnets at 5 degrees to make a magnetic field that would go all the way around. And that's how I started, and I wanted to make these discs spin on their own. So I asked myself, and I started asking, the audience. I would do live streams, how do I get this done? And somebody suggested, DC brushless motor. And then it took off from there. I started with reed switches. And then I moved on to, MPNs. I never really got into PNPs. The MPNs were my home right now. I want to do get involved with the MOSFETs though, and get some speed happening. So that should be interesting. So the Utron, I was struggling with what I was going to do with it, and I decided that I was going to, I didn't want to put anything on it. I wanted to keep the shell pristine. I wanted the outside edge to be nice and straight and smooth. So I wasn't going to put a magnet on the outer edge. Or I didn't want to put anything on the outer edge, And in order to do it this way, I'd have to put, either copper strips or brushes, or I was going to have a serpentine coil going around the outer edge. That was going to be, I was going to have the permanent mag trip the electromag on the side, which was going to trip the serpentine coil on the respectively on the Utron here. And I decided to scrap that idea, and so I built this rotor that is like the way all this fits together is amazing. Because the bobbins that I'm using are store bought. Okay,
Okay.
I bought them from the store, and the magnet size makes it so you can only push it out from the center so far without
Mhm.
reaching the edge of the Utron. So they're out as far as they can go. And when I put the rotor in the middle to see how far away the magnets were from the coils, this thing was meant to be made. I mean, exactly the way it is. And totally, totally cool.
Well, real quick, let's kind of bring everybody up to speed. I want to share one of your videos here
Okay.
so that everybody can kind of see what we're talking about. So this is your
That's my mini Utron.
your Miniatron?
Mini Utron.
Mini Utron. Got it.
Yeah.
So this is the one, man. You got a shaft in it, but you got like a magnet underneath, and it's holding it up, right?
Yeah. Yeah.
I think everybody will see here in a few minutes when you start to pull it apart what it looks like. That's really just awesome.
Yeah. I love how that fit together. And the 4-inch magnets were able to lift it up.
Yeah, look at that. It spins beautifully on there.
It's got 4 Neo cubes in there that form that strong field in the center that I use to repel.
Oh, the coils. Yeah. Yeah, a little bit.
I'll get it.
Okay.
Let's take a look real quick. So you'll finish setting that up, and then
Hey, she can.
So I'm gonna print.
you see how smooth that is.
Okay. And I'm gonna glue that one together. I really want to get some like conductive paste
Right there.
to glue together with. So
Yeah.
if there is
That's unbelievable.
in the copy-
Everybody talks about doing stuff like that. You're the first one I've seen that started to do something. You know what I mean?
So what do we have
It's
here?
balanced perfectly on there for that shaft. So
Motor,
And then
cone on top of a cone. Inverted.
let's see. Okay, so this right here is where you show.
it's a 16 gauge coil setup, so it's a really powerful electromags. Oh, the inside, yeah.
Oh yeah, because this is hard to do because those magnets like to jump.
Yeah.
You have to be real careful.
I don't even know if I take it all the way off here.
I don't think you
You
do.
wanna see
I
in
wouldn't.
between.
Yeah, all the
But you can see the Neo cubes.
Yeah. So I'm gonna do this off camera.
Yeah, they're built right into it.
Because some are sticking in the top, some are sticking in
So-
the bottom.
Yeah.
Let's go into this a little bit. I'll pause this.
Either way, and I don't.
So in this setup, the actual coils that you use, what size were they?
16 gauge. I didn't get the weight on them, but they're about 230 turns of 16 gauge altogether. I have 3 of them, but I'm only using 2 right there. They whip, man, like 3 volts, and I didn't even get a speed reading, but I usually right now I'm using my coil, my pickup coil to basically measure the speed, kinda. and it's up to 180 volts at 3 volts in. So it has a tremendous amount of kinetic energy. It's not really good for like a Bedini charge type scenario, but it's good for using that pickup coil energy. It's really frothy, but you can, if you got the right stuff like a homemade reed switch, be really good for something like that.
Okay. And then real quick, there are 2 windings in there and 1 trigger or 2 trigger on the coil.
In the 16 gauge coil, there's a 26 gauge trigger, and my dual drive coil, I want to discuss that real quick. The 16 gauge is the most powerful coil I have, honestly. It takes about 2.5 amps to run at full speed at 3 volts, but sorry, I'm doing too much at once right now. But the dual drive coil is a 20 gauge and a 20 gauge for drives, and they each have their own trigger. So it's
Okay.
like having 2 isolated circuit in the same bobbin. So when you turn them on parallel, you get a strong interaction between the 2.
So real quick before we go any further, can you just overall describe the pulse motor and exactly how it works real quick so everybody who's not following where we're at right now can kind of catch up?
Now, the very basic idea of a pulse motor is that the magnet or the electromagnet is switched on and off at the appropriate time. And that's basic. The timing is basically positioning. So, how do I say it? It's an on-off. So what I'll do is I'll just
Sorry,
go
I
ahead.
was going to say, as it rotates through and the magnetic field comes around, you need to basically turn it off on one side of it and turn it back on the other so you don't get any force pushed against it, right?
Yeah. Basically, for positioning, that's exactly what you're trying to do. Like the timing, you're trying to have as little resistance or friction, physical resistance or friction in your spin, but you're also trying to get. And I want to demonstrate it. And I've always liked to demonstrate. That's why I do things the way that I do, because I don't like have it on my tongue necessarily what happens. But when I got it in front of me, I can basically say that it spins, and when the magnet passes like the reed switch, it'll make a contact, and then it'll uncontact. So, and when it uncontacts, it releases. And when it it depends basically a lot on which way the coil is facing as to what is happening in regards to the magnet. So you can have an attraction or a repulsion. And there's a lot that goes into the actual doing it. But the basic circuit, you go power supply to the coil to the switch to the ground.
Okay. If you wanted to set it up and run it, by all means, Papa, go ahead.
Yeah, I mean,
Everybody loves the demonstrations, man. Go for it.
I want to get the camera to flop here. There we go.
Oh, perfect.
All
I'm going to
right.
put this on so that they'll still be able to hear us, but it's just going to show your thing.
All right, now these 2 coils are the ones that are on right now. And that big coil in the middle is that inductance coil that I was experimenting with. This 4-inch diameter coil right here. You know, I was experimenting with BEMF and inductance and how much, you know, energy I could get off of that coil. And you know, I don't know. I'm not really impressed with it. And I have a bunch of copper that I was going to invest in making a big, you know, 4-inch diameter coil. It's like a 2-inch, 2.5-inch depth. I don't think I'm going to do that. I might do something else. Now, what I wanted to know real quick, this is the rotor right here that's going to go into the Utron. And these are the bobbins.
Nice.
And they slide right off of there like that. So what I want to know, what goes in here, is it going to be 20 and 32? Is it going to be 32 and 32? I'm only going to make one bifilar coil in there, and then the rest are going to be series connections. Because I was thinking about doing a parallel, you know, each coil with its own power supply and everything like that. That isn't going to fit in there. It's not going to fit. But doing one series circuit will probably work a lot better. But yeah, I don't know what to make the coils, make them straight 32 and have more mass with less current. I think that's what I got to do. Make it all 32.
I agree. I would keep the same number in the first run.
Yeah. 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 Have it all 32. And then the 9-volt battery will last that much longer.
Yeah. So why don't you describe what's going on here?
Okay. So that's our input voltage. Just so, and if anybody was curious, we're about 7 volts in, about 1.5 amps. Okay, what's going on here is when the magnet, and I just want to, let me go through all the components first, all right? You got your coils. These two coils are hooked in series. This one has a 26 gauge trigger. They're hooked to these transistors, MPNs, the two SC5200s from Toshiba. They're a step down from the MJLs. They're a little worse than that, but I didn't want to wait a week to get the transistors, so I just went for the step down. And it's all right. They work really good. But I did run them through this tester, and yeah, they're a little weaker, honestly. But we're going with, okay. Sorry, I had a little bit of caffeine. Okay. Give me just a second.
Okay.
All right. So I don't have like a truly scientific explanation of what's going on here, but I would like to say that as the magnet passes each one of these coils, or it's not each one of the coils necessarily, but as it passes the trigger strand and the base of the transistor is activated or saturated to that point. And here you go. Now it's starting to pick up some speed. So it did take some time, but there it is. The 16 gauge coils, they fire. It's so weird. I'm at a loss for words.
That's all right. Let me give you a little bit of my amateur understanding and see if I'm right. As it spins, you're getting some magnetic value inside the coils themselves. They start to saturate, and as they saturate it, it moves the actual rotor faster and faster. Would that be right?
Yes, we're looking at about, see, look at the amperage is up to 2.5 now for the 16 gauge coils there. And I have an extra one here, a third one that I like to hook up on there just to bring the amperage down a little bit more. But yeah, that that's the downfall of
So,
that.
are all these coils connected together so they get one field overall, or are they all separate going into different areas?
This coil, the big coil is separate from these two coils. These two coils are linked together in series. And then this coil is a pickup coil, which is tied to this cap bank, and then directly in turn to the big cap bank down here, which I'm been charging and using. I'm trying to get some sort of unity going. Definitely not with these coils though. Too much. 2.5 amps isn't going to bring us there.
No, better. I've learned that the higher the voltage, lower the amperage is better for unity in itself.
Yeah, I'd say, and a pulse motor is an ideal, in my mind, way to do that because they run very well on voltage. They don't need a lot of amps to run. I mean, 16 gauge coils, who does that? I do that.
Nice. What coil size do you normally run?
20 gauge, I like, I started out with 32 all the way. I used 32 for a long time. And it worked very well, especially with the reed switch, because you get a lot of mass in the coil. But like for transistor, I found that it was give or take with a transistor, using a transistor, better with a reed switch or even a proximity sensor of some kind, Hall effect.
Okay. That's pretty cool. So you got a driving coil, you got two pickup coils in the system in order to pull the energy back to the cap bank, or was it one to the cap bank?
The one to the cap bank, but the coil is it's a trifilar 32 gauge coil. So I mean, altogether, it's probably like 4,000 turns. But there's a 38 gauge strand in there that got lost, and it's just sticking out right here. And I have one end of it, so if I cut this and use, I can use it still, but it won't be the whole thing. It'll just, and I don't know exactly how I got lost, but when I was wrapping it, I realized that I have lost it.
I've done that myself, to be very honest with you. Those little wires, they're no fun.
Oh, yeah, I do want to show my, it's almost ready. I mean, this would be great if this could actually get done in the stream time. It's really
Boy,
close.
you're building something here. Okay.
It's
What
a
do you-
it's a new Utron shell, so the rotor will be able to fit inside of this one.
Okay. That's okay. Tell us about that configuration because you mentioned it earlier on which coils you thought we should use in there.
Yeah.
What's the difference between having the coils on the inside versus the outside?
Now that is interesting, and it's also limiting in the same way. And it's interesting. Having the rotor on the inside, and having the electromagnets being the things that are actually doing most of the spinning instead of the permanent magnets, which is the typical motor breakdown.
Mm-hmm.
And Typically, also the electromagnets would be on the stator, which would be on the outside. And then in this instance, they're going to be on the rotor on the inside. And it's said, I've been led to believe that it's possible to create like a time rift when the electromagnets are the things that are spinning.
Okay.
I don't know what that means necessarily. That's what I was told. And I'm willing to, try that out.
I'm there with you. I have a Utron as well, and it's a bifilar Tesla coil, and I'm trying to spin it. I didn't build the shaft thick enough, so I can't get the RPM out of it. But I was trying the same kind of concept: spin the voltage, build the magnetic field with it, so that it pulls out from it. I was trying the same thing.
That's awesome. Yeah, I saw. That's a pretty coil too, man. That's awesome.
Thank you.
Yeah. I think that if you want to try spinning it again, you should try rigid couplers.
Okay.
Because I noticed that your couplers were bendy, and you're not going to get a good spin with bendy couplers.
No. That was.
I don't know though. Did you have a reason for using the bendy ones, or is it just what you had on hand?
When I built the coil, I built it the 1/4 inch on the inside. So I went to put a dowel through it. So it's a 1/4 inch dowel, and they're wobbly. So they, you know what I mean? There's no strength to them. So I have to rebuild the coil and make it like a 3/4 inch wooden dowel, because both sides of it are active with high voltage. As soon as you turn it on, they're spitting out energy, right? Because it's a bipolar coil. So I have to use wood or some kind of material that is not magnetic. I'd love to just put a 1/4 inch shaft through there, metal, and be done with it, but it doesn't work that way. So in order to do it right, I had to just build it one more time, build it bigger, and then spin it with some kind of spindle, like a gear, a band, and a motor. That way I can just ramp the sucker up about 7,000 RPM. And then the number one coil sits on the outside of it, so it has no effect on it except for pulling the energy and making it build the field. I'm hoping it builds the same way the magnetic field builds, in the way that as you add energy to it, it pushes the field out further and then drops off a little bit and drops off a little bit. But it's more of the dielectric on the inside pushing out and making the magnetic field start to build on the inside like this. So kind of like the same concept you're looking at.
Okay. I mean, I never really kind of looked at the science, but it makes sense. What you're saying. Maybe I should take a better look at it, like a different perspective. I think that the Tesla coils that I've seen are like they're awesome. And their power is kind of scary in a way. I think with with the big arcs and everything, I have a little one, and I can, harness those arcs in my hand,
Oh yeah.
It's fun, playing around with the plasma. But the big ones, man, wow. I wouldn't do that with a big one.
Well, some of the ones that I have, man, shoot out 13-inch lightning bolts out of the top of them. And then that's in AC, but if you put it in DC, then it builds out the magnetic field. So that's more of where I was going with it. Kind of just like where you're at. You know what I mean? The sparks are great, but they're not great for the science aspect of it.
And if you get that thing spinning at 7,000 RPMs, man, you know what kind of magnetic field you're going to get? Because I watched you messing with your quadruplegic motor thing with the 4, rectangle magnets. And that thing spit in a magnetic field, 2.5 feet away on a 20 gauge bolt. That's huge, man. 20 gauge doesn't register shit. Sorry.
No, it's all right, man. You're good to go.
All right.
I agree with you. It drops off fast. So if we can get 700 to 800 RPMs out of it, man, then we're really cooking. And I just want to see where the limits are. You know what I mean? Set it up at 100 RPM, then go to 200, and then just write down everything as we go and test it. So we'll know. the answer will finally be told to us exactly where we are, how much energy to put in, how much, distance we get, and then we can start building things, based on that.
Yeah.
One of the cool things about the Utron is, and anybody sees in Otis T. Carr, is that
Yeah.
he
Yeah.
has one right in the center of his device, this little UFO device thing. So that's kind of what everybody wants it to build like. They want to be able to build the magnetic field on the inside, which it'll do, where the high voltage on the outside, which is what they're looking for.
So I
What do
made
we
a
got
eight.
going on there? Sorry.
This 8-spoked rotor here has that Utron in the center, like you were talking about just now.
Oh yeah, I see it.
Like right there, yeah, man. And that's what my idea for that one was, to have the Utron in the middle. I want to spin an Utron. That was my philosophy behind this. So I put it in the center of a rotor, and voila, man, I spin an Utron like really fast.
Nice.
So that was just the basic, simple question to ask myself. I want to spin an Utron. How am I going to make that happen? And I started coming up with, different ways that I could do that. And this is what it led to. This rotor right here with the Utron and little Utron in the middle,
Mm-hmm.
and then the big Utron over here, which is going to be the one that I'm making right now. And then the little Utron, which you showed the video of, is there's half of it right there. And then this
Nice.
rotor right here is like one of my simplest but greatest inventions. It's got iron infused PLA on the bottom. So when you put the magnets into the cubes into the slots, it's held in there. You can then turn it upside down, and this thing will float on a toroid just by itself with the magnets in there.
Oh, that's cool.
The iron infused PLA, it unifies with the magnetic field. So it's actually like a very not dense piece of iron around the whole bottom. It is plastic, but it's got a magnetic field. So, it is magnetic.
Right. They put metal shavings in there in order to give you a magnetic field once the magnet goes in. Absolutely.
So I hope.
Was there any reason for the Taurus in the center of that last one you showed? Were you doing something with that?
Oh, you mean this right here?
No, the one you picked up a minute ago. It's got like a donut shape in the center. Is there?
Oh, this one.
Yeah.
Yeah.
Was there something you were trying out?
Yeah, it was. Toroidal was a huge thing when I made this, and so I got the spokes there, and then I was like debating what true toroidal would be, and I came up with this one down here. It's more of a drum roller now. I glued this like the black part on there, but you can see the brown part is a true toroidal that I had hooked up on these stands, and like the poles would go through all 4 of those holes. And the one in the center would have the rotor on it, but those would have the toroidal on it, the 4 poles, and it would spin on those 4 poles because I had bearings and everything. It was awesome. I'm like, dude, this thing is spinning without it like having a shaft. I was like, this is amazing.
Nice. Yeah, I was wondering. Go ahead.
It had 4 shafts. It had 4 shafts actually, but none of them were on the inside. They were all just on the outside. So I don't want to make it sound like it's something that it wasn't, but yeah, it was just so many awesome like triumphs.
Yeah, I was gonna say it seems like there's something new being experimented on or learned or brought into the knowledge base like every week, just because you're wanting to do it and within the stuff that you already have. So I think that's pretty cool, man. I like it.
Thanks, bro.
Yeah, I agree with him. You don't know till you try. They may never tell you everything that's in an experiment when they did it. So it's best to do it on your own and learn the little parts of it that need to be the tricks for the next one and keep going.
So I think it like getting in to I've been working with the permanent magnet side of everything too. So and that's been really inspired by Michael Faraday and what he's doing with his Howard Johnson motor. I think that's really cool, and I want to show you something based on the monopole. So these poles right here are, but all these magnets on in here are Halbeck. They're not facing outward. They're facing left to right.
Okay.
And so it does matter a lot on which way you spin this. But I'm just experimenting with it. I think what he's done is like, it's amazing.
You're talking about Mike over on the Faraday channel, right?
Yeah.
Yeah. I tried. Oh God, I tried it. Let me tell you, Papa, I failed miserably. I suck at this. Okay. Like I figure out most anything, but when it comes to that, I was playing with magnets for like 10 hours straight, trying to get this thing to go the right way and stop doing what it was doing and how the field worked. And I'm drawing pictures, I'm mapping it out on how this thing works, right? And
Yeah.
the obvious answer was to pull it back and forth, right? That was the obvious answer, but I didn't like the obvious answer. So I go, okay, I'm going to take stronger ones and put them on the outside and weaker ones on the inside. Then I flipped them because I didn't like them. And then I said, forget it. I'm just going to take the shells of them and just put the metal on there. And then the metal had the same effect. And I'm going, oh, I'm so lost here, right? So then I go, all right, I'm going to have to do the same thing Mike's doing, no matter what it is, and bounce this thing back and forth. And then, of course, what happens? It starts to work. So, yeah, for all the nincompoop stuff that I did, I learned one thing. When they tell you to do it that way, just do it that way. Because they knew obviously way more than I did.
Yeah, the rubber band trick was freaking awesome. That's right up my alley. And I was like, Mike, that's awesome. Because when it comes in, it pushes it out, and then the rubber band, even though it's not very effective, pulls it back in, and you got your bouncing effect there with your magnet. At least that's what I saw. I'm not sure if that's exactly what was going on. It was a 15-second video.
Oh yeah. And he said the timing with that little rubber band, and then he moved on to, I think it was a piece of copper that was bent, and then it naturally had a spring to it. So
the reed switch that he made.
Yeah, it was going faster and faster as he went.
Yeah, that is, and yeah, it gets into a resonance, and even the paper clips do that. But yeah, man, the contact ability of his switch is impressive. Paperclip is like really sporadic. It's not something you would charge a battery with necessarily. But I think his reed switch, you could definitely charge a battery with that because the contact is pretty much the same every time.
Mm-hmm.
And it's predictable. Batteries don't like unpredictable energy.
Yes. No, I agree with you there. You don't cap it to smooth it? Yeah, you do?
Yeah. I cap it most of the time with I have It's an AC/DC cat bank, but it's AC/DC to DC. So it'll go DC to DC or AC to DC. But it's basically it's got 4 bridge rectifiers in it. It's got 20 DC caps on one side and 4 AC caps on the other side.
Hmm.
So
Gotcha.
I don't
So
know.
You got a big conversion going on there, smoothing it out. Nice.
Yeah, it's really like it's not a cap bank necessarily, but it's like a through. The energy when it moves through it definitely smooths out.
Right on. Well, I sent Micah an invite to come on, man, if he wanted to, so you guys could discuss that a little bit more. But I wanted to get on to you had an Ankh on your channel.
Yes.
Let me pull that up because that was amazing.
Yeah,
So,
my grandfather got that from Egypt actually when he was younger.
very cool. Let's take a look at this. So we see your pulse motor in there. Sorry, I'm just getting to here it is.
Got this. This has been in the family for a while, pretty long time. I believe it might have been used as a door. You should hear it. It's pretty awesome. It's a tuning fork, basically, how it's built, what it's made out of. But it's not like you can bang it on anything. Maybe you can. I would.
Nice.
It was an awesome sound.
Oh, that is resonating
You know,
good.
sound and light and all that stuff. It all kind of says
Yeah.
thing on a different wavelength or frequency.
Did you try the other side of it?
Yes. It doesn't work on either side really or the
Awesome.
bottom.
Solid
Which is
brass,
interesting.
I believe, except it's really high on the copper content because it is getting like in some area.
Okay, sorry, I'll mute the video real quick. Go ahead. So what is it doing? It doesn't work on the sides?
Well, I mean, when you flick it on the sides, it'll work really good, but you got to be holding it upright, like that. When you bang anything on the top, when you're holding it upright, it'll resonate. But when you, like, if I hold it upside down and bang the bottom of it, see, I'm doing it right now. I can feel the vibration, but you don't get the ring. And then turn it upside down or the right side up. Yeah, man. It's weird how the ring happens like that, but I think it's definitely the way it's shaped.
I think it's the way it's shaped too. So I think it has to do with the roundness of it. And I think if you had the roundness on the bottom as well, then it would ring back and forth and do work for you. It would be resonant to each other, going 1 2 1 2, and just be an on and off switch to each other.
Yeah, hell yeah, like an oscillation factor. I mean, that might even be, you know, like Coil classical kind of stuff right there, because whatever happened there was in that little black box, and it was really simple.
Yes.
Whatever it was. I don't know exactly what it was. I don't know if anybody really knows exactly what was going on in there, but we're kind of, I think in this community, we're kind of close to figuring that out.
Oh, yeah. It's kind of like Floyd Sweet. Nobody really knows what's in the box. but from all the descriptions, we kind of have an idea of it's like a, it's just doing work. It's a transformer doing work, which basically means it's resonant to each other and bouncing off one another, which is the same thing we look at when we do the onc on both sides, or I'm about to do the RAV in the same way. I'm trying to set it up in the center where it connects the center, so it has the little shaft, right? The anode, so I could shoot it up and I could shoot it down at the exact same time. You know what I mean? And then I could get the teardrop on the top and the teardrop on the bottom, and they'll be resonant to one another, and they'll start pulsing off of one another. So in one of my other videos, I had them aside from each other, and it's a strange occurrence that starts to happen. Okay, one will get real big, the other get real small. Then they'll do the opposite, and then the opposite like this. Okay.
Okay.
So
Yeah.
as they're building, because it's bouncing back and forth off the same core. So what it's doing is it's like a bipolar core, right? It's like the number one is moving this way and this way as it works. It's automatically doing it, and it's changing the pressure between one and then the other, one then the other. And I think it's the same thing we're looking at with the onc, is if it was built on both sides, it would be resonant to each other, which makes a lot of sense because they've always theorized in the center of our planet, we basically have the same thing going on. And if that's the case, then you can see why it continues to work all the time.
Yeah. Like every time, man, without fail, this thing will ring. And then like, I can see it happening, like maybe when you mirror a mirror image and like having the two tails sticking out and have the circle in the center and have the two things coming up, or have it like more like what you were just saying and have the tails combine and have the ring on each end of it kind of oscillating back and forth. Wow. This thing really is like amazing. The onc.
Oh yeah. I think it's like a mirror effect. Okay, if you take the onc and you place it down on the table, and then you put a mirror in the center of it, right there on the center cross part, right?
Yeah.
What you get is a reflection, but a flipped reflection on the other side of it. So if you can think about that in like a different aspect of the roundness goes to the roundness on this side, the shaft goes to the shaft on this side. Okay, but they spin opposite to each other. So one goes to the right, one goes to the left, and now they're bouncing off of each other in continuous motion.
That would be, yeah.
It's like technology put right in front of your face that you wouldn't know until you built it.
Yeah, I agree with you. I mean, I'm kind of following with you as you discuss it, but I agree, man. Without that hands-on experience, you're kind of, it's kind of like doing a math problem.
Yeah, it is. You just don't know all the factors yet, but it makes sense when you start thinking about it. And we were looking at what's his name? He does all the math on the stuff in physics, right? And he kept running across the problem. And the problem was simple. He couldn't get the thing to equal each other on each side. So what did he have to do? He had to take the fraction and flip it. And then make regular fraction, take another one and flip it in order to cross each other out, in order to make it equal one to the other. Well, this explains why.
What is that?
And the shape of things matters a lot. And then I guess the starting point where you're measuring from matters a lot.
Yeah, especially where you start your coil. Like when you're winding a coil, where you start it is, you gotta mark that down pretty good. Some bobbins have a little hole in the center that you can like mark your starting point that way. But Yeah, when you're putting your power in, you want to put the power going into the start of the coil where you started it at, and then you want the power to come out where you ended at. And then you got to wind it a specific way to have that effect, to have a desired effect when you do that. So counterclockwise, clockwise, left to right, you know, attraction phase, repulsion phase.
I have a question for you.
Yeah.
You say it goes from the coil, it goes then to the reed switch, and then it goes to the ground. Okay.
Yeah.
What do you think the ground is playing here? Is it pulling energy from the ground, or is it pushing energy to the ground?
In this instance, I would say that this circuit is definitely it's could go either way, honestly. But I think that the energy comes out of the negative of the battery. So it's definitely a pulling sensation, especially with the way I set it up, because I have a halogen bulb on the one side that is 120 volts. So it pulls through. But I'd say this is more of a hot circuit than a cold one, honestly. I think the way I set it up, it definitely pushes through instead of being pulled through.
Okay, so is the negative, when you say ground, are you saying that it goes to the negative of the battery, or you're saying it's going to a lead to the ground in the wall?
No, not the earth ground. The
Okay.
ground on the battery, just to complete the circuit. But yeah, I was watching the presentation with Elijah's pulse motor demonstration, and I saw him with the wire connected to the ground at the lamp.
Mhm.
And I was so intrigued by that because I kind of figured what was going on, but I had no idea you could draw power out of the ground like that.
Oh, yeah, you can. Oh, yeah, very easily.
Yeah, that's amazing. I mean, if I ever have a problem, does it register with the power company like you're taking power from them or not?
There's a couple thoughts on that. So some would say no, and then others would say that is taking the meter and playing with it.
Right.
So I don't know that you'd ever want to tell the power company that you're doing it if you're doing it.
Oh, yeah, I definitely don't do it, but I mean, yeah, I would keep it a secret too.
I was thinking that in your coil, and just tell me if I'm way off base here, because you're pulsing it in and out, right? It's almost like a vacuum effect. So you definitely pushing the energy in, right? And it's causing the primary effect. But then that's off for a second, right? And I'm wondering if it's sucking the negative back through it to it and then hitting it again. You know what I mean? If you don't have a reverse, a little bit of reverse coming back into it.
It also depends a great deal on how big your axle is. If your axle is, if it's proportionate to the amount of copper you have in your coil, diameter wise, you'll get that effect, that vacuum effect, really. And like what I'm getting at, I think you understand. Like the hole in the middle, if it's equivalent size to the amount of copper you have on the outer rim of that, then that vacuum that you're suggesting is very strong. It's like a perfect fit. Yeah. But like if the hole's too small, you'll get that overlap like all the time. Like that's just how it works when the hole's too small.
So is there a certain size that you would recommend that you have in there?
Well, I made this one an inch so that I could use my powder filled cores. I have them over here. They're iron powder filled. So I don't know. The iron powder is roughly 80% iron or something like that. It's 60% iron. I'm not sure exactly how much iron's in there. But the size of, I would make it the same size as the coil. So I would make it so that if you were going to put a core in there, the core material would be the same mass as the amount of copper you have. That's what I would do for my perfect coil.
Gotcha. Nice. So do you
Yeah,
get a lot
and-
of energy out of that center part when you put that the iron in there?
Yeah, I get a nice boost in generation, and I get a nice boost in electromagnetic. What is it called? Not
This
force, but yeah, the flux. Yeah, for the drive side of things, it helps out a little bit too. But honestly, the air core for the 16 gauge coils, phenomenal. Like awesome. So
Now,
I don't.
I
Go
got
ahead.
a little bit of a question for you. Have you ever tried to tap the energy in the center of the actual core itself? Just like put a wire in there and see if you can't get anything out of it to light a light bulb or anything?
I have not been able to do that, and I'll tell you why. All my cores are like either like a unit like this, where there's or like this. So I could probably we could experiment like right now. But the problem was is I use clips, and the clips wouldn't clip any of the cores, the material that I have. But if I use welding rods, I heard that welding rods are really good, especially the copper infused welding rods.
Mm-hmm. Yeah, Mike says also copper, like how do I say, like BB gun copper
Oh yeah,
for a thing in there too. Yeah, it had the same effect.
yeah, like shotgun pellets.
Yeah, there you go.
All right, cool beans, man. Yeah, for sure.
There's always a way
That
around it, I guess. Yeah, he also said on his he runs piezoelectric discs on the negative side.
Okay.
And what those things tend to do is they tend to be an amplifier for voltage.
And is he running them in series on the negative side, or is he running them in parallel?
I believe
with the
he's
coil.
running them one right after the other. So he's in series on them.
All right. Yeah, that's the difference between and the way I'm using them aren't having much effect. So, and I've been running parallel with the coil, so I'll try that.
It's just interesting. I found the same effect when I do other projects with high voltage. It's amplifying the voltage itself. It's just bringing up the frequency. You know what I mean? So then it pushes through with more voltage, less amperage, and it kind of gives you a little bit more in the end.
Yeah, and I get it how it works through audio and audio amplification. That's really awesome.
Right on. Sorry, I'm reading the comments here real quick. There's a lot of people out there, man, that just love the way these things run, man. So
It's cool.
a lot of people. So everybody knows. I started watching Papa Bale's channel a while back, and every time you go on there, man, he's got something different going on. So it's never the same like configuration or anything. Like some of the configurations are the same, but like a lot of the hookups on how he does it, and you know what I mean, where all the wires are going, you got to pay attention because they're going to be going in different places sometimes and looking for a different effect that's going on. I think that's what's so awesome about your channel is it's all live. Everybody gets on there to watch it, you know what I mean? And you're interacting with everybody and then moving things around and changing them and then getting different results altogether based on what you're putting in.
Yeah, yes. And the different results is the awesome part, how it breaks down. And you know what I'm looking for? I'm looking for that one number that's going to show us moving in the right direction. And I'm not just talking about a battery adjustment or a cap bank adjustment when you move something on the board. I'm talking about that charging effect that eludes. This has been elusive for everybody, as far as I can tell, to have that charging effect in the closed loop system.
Gotcha.
Virtually impossible, as far as I can tell so far. I mean, I know that you have an over Unity build that works on the drawing of the power, the cold circuit, basically.
Oh, yeah. Well, I do it based on the amplification of the resonance. I'm not necessarily looking for the power to go up. As a matter of fact, every time I turn it on, I turn the power down. I have to have it at a certain level for the actual transistor to trigger, but I can get it down to a 3-volt battery and still light another coil up 2 feet away. You know what I mean?
Wow. Yeah.
Because I learned how to amplify the amount of resonance in there so it travels further. And that's all it takes to turn on another coil. You don't need voltage and amperage are useless to resonance once it gets out there. They're just a push. You know what I mean? They're just a placeholder for what the actual energy really does. So it's kind of a whole different frame in your mind. You have to think of it because a lot of people get lost in how many amps, how many volts. It's like, doesn't matter.
I've been getting into frequency and working with just my basic coils. Like I'll have my basic trigger strand hooked up, and then I will use the
Hey, Mike, what's going on, brother? Thank you for coming in, man.
Yeah.
What's happening?
So, how's it going?
Pretty good. Still
yeah, man,
recovering.
Digging the Sepultura.
Yeah,
man, that's great music.
that's what I grew up with. Shows my age.
Hey, Mike, he was talking about your last coil that you're doing and how the switch works.
Oh, yeah. What, the mechanical commentator?
Yes.
Yeah. That's got an awesome contact. I just got to say, that's great.
Well, it's kind of got 2 jobs. One of them, obviously, is opening and closing the circuit. And then the other job it has on the rebound, as the magnet is passing on the rebound, it's pushing on the magnet. So now it's creating extra mechanical or magnetic force to push that wheel away.
So you're telling me when the switch bends, it pushes the oh, wow, dude. That's awesome.
So see, with the Howard Johnson motor, his design originally, his conclusions were you can get continued acceleration of magnets in a linear motion. But here's the but. The second you try to put it into a rotational motion, you don't get that same effect. You lose it. So if it's going in a straight line, it will continue to accelerate in a straight line. So that's where he found out his limitations. To actually set up that device in a circular device is extremely hard and almost next to impossible. He was able to do it, but the problem is the amount of power that it was generating because, going in a circular rotation, the magnets can't accelerate.
Okay.
So you can never get over the hill, so to speak, to keep accelerating. In a linear motion, yes, you can get continuous acceleration. So I kind of
gave it that extra little push with the coil every time it closes the circuit. It gives it that little extra push that it needs to get over that bubble of the field.
So
Soon
that
as it
coil, what does it do exactly?
It basically just gives it a little bit of a magnetic push, just enough so that magnet has enough to flip over from
Wow.
the left to right to the left. So if it's going in clockwise direction. So,
Okay.
and because it's on a spring, you got the mechanical spring pushing on that wheel with a magnetic field to push against the magnet, opposing magnet on the wheel. So now you're getting the benefit of that switch bouncing back and forth, helping and assisting the power rotation of the wheel. So it's doing two things at the same time.
And I think your wheel is moving extraordinarily fast, man. That's awesome.
Yeah, it's I say it's about hitting about 700 RPM. I got to put the tack on it tomorrow to get a
Nice.
real
Yeah.
proper reading on it. But my goal is to get it up to 1,000 RPM.
That's cool. And I mean,
And
the way you have the light set up in your video, man, it's awesome how it hits the motor, the wheel.
Oh yeah, that's just pure sunlight coming right through my storage locker because I
That's
built the
awesome,
lab.
dude.
I built my lab in the storage locker because my wife kicked me out of the house.
Oh no.
So I got evicted. So I got a 25-foot storage locker that I've now retrofitted into my lab.
Okay.
Nice.
And then I got two off the grid, 2 kilowatt inverter systems hooked up in there with about almost 5,000 watt hours of power in there now. So I can pretty much run anything I need in that locker. And I
So-
got a full
I got a
solar
question for
array.
you, Michael.
Sure.
Are you related to Faraday?
No, not in any
Okay.
way. It's
All
just
right.
happened. I just happen to have the first name of Michael Faraday. So,
Right, right.
and all
Yeah.
my work is based on his engineering. Right. He's one of the forefathers of
The pulse motor.
electromagnetic induction. Right.
Yeah, yeah. His yeah, that discovery of his is the foundation of this whole.
Yeah.
Like,
It runs the whole 21st century right now. It's still based on his ingenuity and his discoveries to this day, and it stands firmly.
So I have a question for you, Mike. You said that in linear fashion it would accelerate, but in a
Right.
rotational fashion it doesn't. So
It doesn't.
in Edwin Gray's device,
Right.
he has magnets going up like a piston, and there's
Right.
a crankshaft underneath. Would that
Right.
accelerate?
Yeah, it would. And that was the whole basis why you got such big over unity. That's why they
Yeah,
went after them as hard as they did.
I said a piston would probably work best, or a piston mechanism.
Yeah.
I
Yeah.
think that's right.
Oh
So
wow, that's interesting. That's like a whole nother line to what you guys do. You know what
yeah,
I mean?
like the Edwin Gray system, you have to understand, runs on extreme high voltages. So like typically when I run a pulse motor is minimum 24 to 50 volts. Anything under
Okay.
that, you're really wasting your time because you have to build a field in that coil. So when you super saturate that field in the coil, by the time the next cycle comes around, that coil hasn't fully collapsed. So you're actually hyperinflating that field, but you're pulsating it. It becomes like a heartbeat, right? So
Right.
keeping
Yeah.
the coil saturated all the time keeps it always ahead of the game, so it doesn't have to draw amps from the battery. So my systems, if they exceed 100 milliamps, there's something wrong. They should
Okay.
not exceed 100 milliamps. So if you go at 50 volts, I can get it as low as 20 milliamps of
Wow.
input current and get
That's
better
cool.
effects and better output. So my big Renegade device, the high voltage spikes I recorded on is hitting about 960 volts.
That's good, man.
That's an extreme high pulse. And that's off a
That's-
2-pound coil.
about 200, volts higher than the range that people desire. That's amazing.
Oh yeah, it's way higher. The pulses are extreme. Now I took that to another level too, and I really wish you would try this. Is
Okay.
hooking up a barium titanate transducer to the circuit.
Oh, we're talking about that.
You're gonna see your potentials go through the roof. Your currents are gonna increase. Your top end voltage is gonna increase. You'll notice if you have any spark gaps in it, it will increase the spark gap size. It will take your project to a whole new level. You can buy them on
Okay.
Amazon. They're like $9. They're about 2-inch discs. They're like a ceramic material, and they're made
Okay.
of barium titanate. They're only like $13, $15 on Amazon. They're very cheap. Hook that up in. You can put it in series with your positive end of your coil going out, and you watch the magic happen.
Okay.
So I have a picture for you here.
Yeah, there's my circuit. So
Okay.
you can do them in parallel or you can do them in series with the coil. So you could actually technically short your coil out with the transducers in between positive and negative side of that coil, and it will still work, and you'll get potentials you've never seen before by far.
Okay, and that's using vibrational
Yep.
amplification.
Right. So what you're doing is when you create that pulse in the coil, that now hits the piezoelectric material inside the transducer. So basically a transducer, a piezo transducer, barium titanate, there's many different types, but those are over unity devices, right?
Okay.
All on their own. So if you hit it with a high voltage spike, say you get a 200 volt spike coming off your coil on its own, that transducer is going to double that power.
That's awesome.
So
I got little piezos, but
Yeah,
you're talking like a bigger one?
yeah, they're about a 2-inch round disc. You get them on Amazon. They're like a ceramic type material. There's different
Yeah.
types. They usually run about 41 kilohertz. They're about 20 to 40 watts capable. You can. There's ones that are shaped like the triangle. The ones they use for ultrasonic cleaners. It's the same type of transducer you want to look for.
Okay.
But they're pretty beefy. Some of them get pretty heavy. But I'm telling you, you play with those and you'll be amazed right away. You'll see results
Yeah.
right away.
Hey, Mike, if you send me a link, I'll send it to Papa Bale so he has it.
Yeah, I'll send it to you, and then I'm doing all this on my cell phone right now, so
No, don't worry about it. We'll get it later.
Yeah.
I wanted him to be able to talk to you about it because it was one of the differences I seen between your guys' pulse motors.
Yeah.
Is that you were running that in there.
Yeah. See, like if you go back to Robert Adams, the guy who I based my whole design on, he always had a mechanical commutator. So
Yeah.
whenever I see guys doing pulse motors using MOSFETs or SSRs or whatever, I cringe. The hair on my back starts going up because it drives me crazy every time I see it. Yeah, the power is transient, yes, but you're releasing potential in its natural form, like a lightning bolt. All right. As soon as you start messing with it, you lose its power. So at the end of the circuit, when you're ready to do something with that potential, you want to put it into a high voltage full wave bridge rectifier and dump it into a nice size cap. And then after that, put it through another bridge rectifier one more time. Okay. And this is where it gets interesting. Now you can take that power and feed it right back into the motor, and the motor will not short out.
Really?
You break the symmetry. All right.
Nice.
And that's that idea I got from Tesla. So put it through a rectifier, dump it into a nice capacitor, and then from the capacitor to another bridge rectifier one more time, and then feed it right back into your drive battery. And guess what? You got a fully looped system that does not short out. Guaranteed.
Will it charge up though?
Yes, it will.
Awesome, man. Awesome. That's what I've been looking for.
Yeah.
Something
So you
that'll charge itself, basically.
Yeah. So if you're getting enough potential, that battery, in theory, should not run out of power. So if you got a motor that's running under 100 milliamps and you do what I'm telling you, it's a self runner. It would never die.
Okay.
So let me ask you something, Mike. In the self-running system you have, what is the battery actually doing in there? Because I saw you using little small ones or big
Yeah.
ones.
They're just it's just a reservoir. It's just to when you add a reservoir into the system, what you're doing is you're buying yourself time on the cycle,
Mhm.
right? So if you're cycling power through the system and it's a little bit slow, and you add a capacitive value to the circuit, now your motor has time to catch up. It's creating a buffer. So now you're always staying ahead of the game, right? You always have that little extra power sitting in the system that will sustain everything and keep it running.
So
Like
is that why you had the 9 volts in your system at that one time?
The 9 volts, yeah, you could go as low as you want, but I just came to the conclusion that working anything under 24 volts is you're not going to see the results you want. So I really encouraged going 24, even 50. Like my big Renegade, I run 52 volts through it.
Oh no, I was just asking about the battery aspect, not how
Oh,
much voltage you're.
the other battery,
Yeah.
that separate battery just runs the switch. That's
Okay.
it. Yeah, it has nothing to do with the rest of the system. It's completely isolated from it. It's just basically to keep the switch running. But that's the mechanical switch.
Oh, okay.
Yeah. So, yeah,
Yeah.
best suggestion. You know what? I've seen thousands and thousands of videos of pulse motors, and not one guy has tried the transducer. And it was a game changer for my research. It really was. And
Well, Papa
Well, I
was
use a
saying that he
Pezos.
did it.
Yeah, I use Pezos, but I use them in parallel. I'm going to try using them in series now
yeah,
because
try in
what you
series.
said. Yeah.
Try in series. Yeah, on the positive end going out. Yeah.
I love how they click, man. The ones that I got have the copper base and then the ceramic in the middle.
Yeah,
They
yeah.
click. I love it.
Yeah, they click, and if you take that transducer and you put it on your skin, you'll get a really interesting sensation, and it actually helps you. I'll leave it at that. I won't go any further on that.
Gotcha.
But I want you to observe a body part that might be hurting.
So,
Like my
when
ankle?
You say we're
Anything.
not going to go that much into it, guys.
All right.
We're just amplifying, we're bringing the frequency up. Mike, what is your thought on what's going on with those Pezos and what they're doing?
Yeah, well, they're tuned for, the ones I have are tuned for about 41 kilocycles or 41 kilohertz. So when you're hitting high voltage in it, those crystals and the barium titanate and the quartz crystal, they're getting activated and they're causing stress on the inside. And that stress is what creates electrical current and voltage. That's why there's such a huge potential gain. Like when you get a standard one and you press on it, you're exerting a mechanical force on it and you get voltage. You could light up a small LED with it. But I had the crazy idea of what would happen if I hit it with some voltage. Well, guess what? It gave me double the back.
Heck yeah. Because you force it to contract. And then when it does that, yes.
Right.
Oh, wow.
You're creating a charge. It's amplifying the charge that you're sending through it instantaneously and very violently, I might add. Yeah.
Yeah.
You ever try to point those at each other? Would they do anything? Would the fields cross?
I haven't really toyed around with that. I usually use 2 in a circuit. I use 2 of the ceramic ones in series. So that seems to work pretty good, especially if you're going to be pumping 50 volts into your coil, the drive coil. I like to use 2 of them. And excellent results. It's pretty much unanimous what they do.
Nice. Look at that. Papa's building Utron or Utron, however you want to say it.
Yeah.
Utron?
Yeah.
Right on.
Yeah, it's got a hollow center that I'm going to put a rotor in,
There you go.
and
Yeah, that's the
I'm
other
gonna-
thing too. A lot of people don't realize that the wheel creates a lot of drag spinning. So if you can put it in a contained unit, get that air drag down, you'll get better performance.
oh yeah, 100% enclosed. This is
Yeah.
going to be great.
Yeah. That'll help. All these little things that a lot of people overlook. Sorry, phone call coming there. Yeah, all these little variables adds up in the end. Because what you want to do, especially with a mechanical pulse motor, is eliminate the losses in any way you can. And wind
I
drag
agree.
is one of them. So, and also
Neutron.
use ceramic bearings, because that will affect your spinning. If you got a lot of magnetic field going around, it could actually couple with a steel bearing and slow your motor down.
Yeah.
Really?
So,
Didn't know
yeah.
that.
So you're talking 100% ceramic, not a hybrid, right?
Oh yeah, they're about $15 a pop for those small little bearings.
That's a good tip. I'm going to have to remember that one.
That's what I only use now, ceramic bearings only. When I built the end machine, first Depamas machine, I had to use them because the two fishing magnets, they had a lift force of over 700 pounds each. So if I had metal bearings in there, it would just cog right up and it wouldn't go anywhere, right? So I had to use pure ceramic bearings. And that's another device that is interesting. I'll leave it at that. That's a little bit of woo-woo happen with that, right?
Yeah.
So I got these ceramic steel hybrids for my Utron. And the reason I got them is because they were the highest, RPM based ceramic bearings that I could find.
Yep, they'll work.
But I'll definitely be going 100% ceramic to not interfere, have the magnetic fluxes interfere with that.
Yeah, I just find they spin better. They run more freely. They are a little bit noisier. I actually I wouldn't really even consider them noisy. They just are a better spin on them, less friction, more durable.
Hell yeah. They spin forever, man. It's like 28,000 RPMs. Well, it said 280,000 RPMs, but I think that was a typo.
Wow. Yeah, like my wheels when I build them, if I'll spin it with my hand really, really hard, that wheel should sustain a spin for a minimum 1 minute or longer, and then you got a good wheel. So even having a little bit of weight, like a flywheel type thing, have more of the weight on the outer perimeter of the wheel than in the middle. You'll have more of a flywheel effect, and you'll have more inertia built in the wheel as it's spinning. So that also helps too. So it's all these little variables I've learned over the last 10 years building these motors. Every little detail will count in the end.
Yeah. So do you maglev? Maglev, yeah.
I haven't really experimented too much with it. I'm kind of old school. I like my bearings. But
But using bearings, but just have a magnetic to elevate it.
application on it, yeah, because you use basically just an axle, right? Yeah.
Yeah, I use an axle, and then I have the two toroid magnets to repel, one on the rotor and then one on the table.
Yeah.
And it elevates it on the pole a little bit, so it reduces that friction a little bit. But then again, it has a whole other set of problems that go along with it.
Well, yeah, because when you got spinning magnets like that, if there's anything around it that's metal, it'll create eddy currents, which actually could be detrimental to it too. So you got to be careful of the environment where it's spinning on. If you were to have, say, a copper plate underneath it, that copper plate after a little while will actually start heating up because the eddy currents from the spinning magnets will transfer to the copper and heat it up. So
Wow.
Just but from what I've seen how you're doing, I don't think it will affect anything. You should be good the way you are.
Yeah, I
But
got
I
forced
like how you
into.
I like how you experiment. You're open-minded, non-biased. You have a very kind of like a natural way of just going through stuff, and whether it's right or wrong or whatever, you just try it. And I like that. I admire that a lot. How you go about doing your stuff. So keep it up.
Well, I'm not afraid to show people that I screw up a lot. You know, I like having the full documentary of what's going on.
Yeah,
That was the initial idea.
but you know what? That's part of your own personal education process. You're learning what works, what doesn't work, regardless of what the outcome is. If you have 5 failures and 1 success in a week, I chalk that up as a good week, because you're slowly but surely you're climbing the ladder of knowledge on what works, what doesn't work, what combinations work, what doesn't work. So
Yeah,
it's a personal growth thing, right?
absolutely. You know, like you really inspired me to work with the permanent magnets a little bit, you know, more than I have been lately.
Yeah.
And, you know, I got back into it, and, you know, I've been working with, you know, monopoling stuff and, you know, all that good stuff. And I'm using held back array on the wheel now. So the magnets are facing left, right.
Right.
And then I'm using, you know, the washer magnet and the iron on that to make it, you know, one pole.
Right.
And then, you know, having the haul back, spinning it one way or the other, you know, actually greatly, you know, affects how well it performs.
Yeah, for sure. But like, even, you know, when you grab 2 magnets and they're opposing each other, you can feel that field. And when you
Yeah, hell
learn when you learn the proximity of how far that field is coming out of the magnet itself, now you know how far that coil's got to be from the wheel. Because I see a lot of people, what they do is they jam the coil way too close to the rotor, way
right.
too close. Because in the electromagnet, when you're pulsating it, now you're creating a spinning current going around the coil. So all you need to do is have the magnets from the wheel ride the wave that's being created by the electromagnet of your coil, and give it a nudge. It's pushing it, it's riding the wave. So you're not trying to cram it in. That creates cogging that'll actually slow you down. You
Well,
want to get
people
it.
like, they say the reason why people do that, I believe, is they say that, you know, doing that creates more torque. And I'm
Yeah.
like,
Yeah.
that might be true, but
Right.
you're losing a great deal of speed by doing that.
And you're going to draw a hell of a lot more current,
Yeah.
because now you have to play with the lens effect.
Yeah, that effect sucks. You want to avoid that.
Exactly. So that's the reason why most of my coils are about a 1/2 inch away from the wheel. And because of that, I can get great speeds, and it takes less than 100 milliamps to run the system. So the key is the input voltage, number 1. So if you boost your power up to 50 volts, your current demand goes way down. It'll go under 100 milliamps if you got it set up correctly. And your motor's going to fly, and you're going to see high voltage spikes like you've never seen before. And those caps will charge 10 times quicker with twice the amount of current going through it. So,
Heck yeah, sounds good. I mean, it sounds not too good to be true, but it sounds like a few minor adjustments.
yeah, like if you see some of the old videos with Paul Babcock when he talks, he has this funny saying when he was doing his conferences. Says, "Don't be a wussy. Stop using 12 volts."
Yeah, I saw that. I saw that.
Right?
I actually
Right?
saw that video.
Right. And that was just before he passed away. He said that. So I 100%.
Oh no.
Oh yeah, he
Okay.
passed away. Yeah, he passed away A year ago in June, he passed away.
Oh no, man! And if it's the same guy, the same video, that's
Yeah, Paul
terrible.
Babcock. Yeah, yeah, he passed away. Him and what's his name? Jim Murray. They used to do a lot of work together. Yeah, he's gone now.
Oh wow.
Yeah, there's quite a few people have passed away in the last year, or last couple of years, anyways. Yeah. So there's not too many of the old guys left. We're kind of like the new crop coming up, right?
So I hear good things coming out of like a Don Smith type of
Yeah, I've
solid
worked a lot.
state combination of stuff.
Yeah, I've worked with a lot of Don Smith stuff, but I must warn you, when you start playing with spark gaps, you got to be very careful because some of this stuff is you can potentially start creating emissions that
Yeah.
are not very good for you.
Okay.
I think that was part of some of the reasons why Don Smith got sick. You start getting strokes. I think he was exposed to quite a bit of X-rays and maybe possible beta or gamma waves coming off his spark gaps. And you got to be very careful. I have a Geiger counter now that
Okay.
if I'm working with a heavy duty spark gap or a plasma, I'll fire up my my Geiger counter just to take a reading what's coming off it, because you don't know. Sometimes you're tickling molecular structure that you're not sure of. You know, like my Don Smith generator, I had 11 kilovolts going through it, and with that amount of power, yeah, something could happen. And the worst part is you can't see it.
Yeah.
You could be getting damaged, and you don't even know it, right?
Mhm.
Right.
So
Yeah, it's scary. It is really high voltage. I mean, he made his own capacitor that was like, 900,000
oh yeah, it's
voltage
ridiculous.
or something crazy.
Yeah,
it was
When
amazing.
yeah, when you're playing with voltages that high, you have to take extra precaution. I'm telling you. You know, some of these guys they get a little too into it and then totally forget about some safety aspects of it, right?
Yeah.
So, just so you know, from playing with high voltage, my ring finger, the knuckle on it, normally it gets a little bigger because your ring's on there messing with it all the time.
Yeah.
But if you're around high voltage enough, what happens is it goes way too big. I had to cut my ring off with my finger.
Oh,
Because the too much high voltage. Because I was
yeah.
doing high voltage every day, messing with it, and it messes with your body.
Yeah. And I think that's what happened with Don Smith.
Yeah.
Yeah. I really believe that. Yeah.
Yeah.
And he was working with some like 40 kilowatts or, he's working with some high powered stuff.
All right. So the Utron is printed. The first half of it. I'll show you.
How many hours?
Like 3.5. It's really light. I've designed it to be really light. It's honeycomb infill,
Okay.
15%.
Yeah.
And I gotta dig out the pieces. What I'm trying to say. What do you call it?
The
Yeah,
infill,
so-
Yeah.
you're gonna peel it out and
The support.
hog
The
it out.
supports.
Yeah, the support
Yeah.
material. Yeah.
Yeah. But anyway, this comes out, and then the rotor slides right in there.
Yeah.
And it's gonna be awesome.
Yeah. I'll definitely tune in to see the results of that.
It's 8-inch diameter. It's just weird. I think it's divine. It's divine how like all the pieces that I put together
Mhm.
came together. Because I mean, half of it's store bought, and the other half. And the reason I say this is because there are 4 neodymium magnets inside this Utron, right?
Okay.
Inside here, and they're pushed out as far as they can be pushed out. If you push them out any farther, then you're going to breach the shell of the Utron.
Right.
So they're out as far as they can go. And then you put this rotor in there and it fits perfectly.
Right on.
So, I mean, like, it was like, oh, wow, this can't be any more right.
Yeah. Yep.
Yeah, I feel great about it.
Cool.
Hey, how are you guys doing? Be sure to drop a. My daughter
Anyways,
just got home.
I just dropped by for a little bit to say hey, and I don't want to kill your spotlight here, so I'm gonna jet for the day. And
Oh, thanks for stopping by. I really appreciate your input, man.
yeah, I look forward to seeing what you're gonna do next.
Thank you, Mike. You too,
All right,
man.
guys. Okay, take care.
Peace.
Hey guys, let's real quick get into what you're doing, Chris. What do you got going on your channel?
So I appreciate the opportunity. My channel came about a few years back. I think I created it in 2020, and I, mostly put content on it a few years ago. But kind of there's the basis of the entire channel is to kind of focus on the promise of future tech, future ideas, future processes, future understandings, through the convergence of multiple innovation platforms that are kind of developing simultaneously right now on their own. And by innovation platform, I mean something that changes the way society lives. So the last time we saw this many innovation platforms going at the same time was, over 100 years ago when we had automobile, telephone, electricity going up at the same time. So now we got AI, robotics, blockchain, energy storage. So there's a lot to be discussed in that one. And then sequencing. So genome sequencing, multi-omic sequencing. So these 5 innovation platforms are kind of all converging with AI at this point, but some have converged together with each other. Like, for example, some would call a Tesla automobile the convergence of robotics, AI, and energy storage. So, there's like a way to look at these things in terms of how they develop, but it's not just that. It's like any one of these things can converge with anything else. So like finance, blockchain, and then you get decentralized finance. Education and AI, and now we're starting to get tutors that are just as good as paid tutors. For you still pay for it, but it's like it's in that monthly cost that's still higher for the normal individual to obtain right now. He's working on it.
Oh, it's all good.
My bad. I can't hear it.
No, you're good, bro. But it's like I find it fascinating because it's just an understanding of like how we move forward in just a piece of our existence and how we use it. So we converge things together to get to another understanding. Usually, don't get me wrong, there are leapfrogs. But usually our understanding is like a convergence frontier. So I kind of believe that in this rapid acceleration that may become exponential with the addition of simulated AI on top of everything that we've done, it's going to be an important. Hold on, this is really, really loud, and he's right here.
Sorry. I'll be done right now.
Okay.
He left his camera there and he moved over towards you and made it louder.
My bad.
That was awesome. But it's looking good. The whole is it's like a boring. So I want to kind of build a plot that's kind of a lens, I should call it, a foundational lens, which I look to the future through in with the promise. So focused on solution oriented kind of content instead of pointing out what the problems are. We know what the problems are, and usually our solution is to say, hey, let's advocate in this way, become an activist for this, try to solicit our elected officials, all these different things. When when we're getting technologies that are blockchain based, so decentralized in the same kind of essence, and so if we get governance through decentralized autonomous organizations that are more reactive and we can feel the impact of quicker after a vote, aren't we going to be more inclined to vote there? Assuming that these things would happen in that way. So like there's a lot of changes that could be very rapid and impactful and felt just by converging with blockchain. So
so let me take a stab at what you're saying here. So it's like when cryptocurrency meets AI versus where we're going in the future with it. You're showing like a view of the positive about how it works out.
Correct. So the positive can be each cryptocurrency platform is built for its own purpose and is trying to bring a value into the world that makes sense for its team or some kind of socioeconomic change that it wants to create. So in my opinion, a lot of these decentralized open source co-op platform initiative type operating systems are going to start to proliferate once true decentralized competition comes into play. So you need a few things for that to happen, and one person, one vote is one of those. So one biometric, one vote. So it doesn't matter how many of the token you hold, if you hold any, you shouldn't have to hold something to vote. So that mimics like the current it mimics the current structure for like stock holding. Like the more stock you hold, the more your vote matters. So and then even in voting for people, we have gerrymandering, which is a real thing. And we change our own laws to create independent committees and entities that can work to mitigate against some of these things. But
well, hold on, I don't know that holding more stock and getting more voting power is a good thing at all. I think that's absolutely horrifying.
Yeah.
I think that ruins our whole system and turns us into an economic nightmare.
Yeah.
In the future, I'm completely against that.
So that's the importance of one person, one vote.
There you go.
So that's what I'm saying. We don't see many of those right now. We see some trying to give the people that hold less more of a voice. So you can have like 6x, 10x, voting power if you hold less than this amount, which I mean it's a good step, but you truly need to have it be even the creator team becomes one vote. Any entity becomes one vote. Any person becomes one vote. And that's a true decentralized competition, and they are out there. Just the user base isn't large in these things, and it's not robust yet. But it doesn't mean it won't be there, because it already exists. And if our AI agents discover it, and so we don't have to, can that create the robustness that platform needs to take off? So
It sounds interesting.
mhm.
I don't know that I agree with it, but if you got
That's
a
all right.
positive spin for it, you know what I mean? I'd be happy to hear that. That's pretty cool, though, because you go into quantum computing and then you go into AI. The two interlink no matter what you do. You know what I mean? How much faster can you get it? How much more knowledge do they have? And how fast can you put that to the market? That makes all the sense in the world when it comes to like Bitcoin and stuff, where it's all on a digital platform.
Well, and like exactly. So digital is one thing, but we're about to capitalize these things, capitalize in knowledge and information. So it's like, with the right tools, someone can become a commoditization of problem solving, just a commoditizer of problem solving by using these tools that are becoming available. So a good way to think about it is the one vote, one person open source platform initiatives are going to be built around the necessities. So they're going to build a global safety net that have to do with water, food, shelter, clothing, education, healthcare, transportation, electricity, and internet, all 9 things. And we're going to be able to contribute to, the future direction of these and be able to, lift the dependency we have on our centralized institutions because of this. So like the energy is there. It's always been there in a decentralized fashion. Just now the technology can bring it to more people quicker. And with the centralized institutions just coming into play now, with all the bills that are about to pass, Washington and then other areas after they see what we're doing, is my guess. That's going to get a lot of people into this space, but it's still a transformative space because it's a Web 2 to Web 3 connection. It's a traditional finance to decentralized finance connection. And it's only when, enough people get into this space and then swim out into the decentral on their own, which I hope they would be encouraged to do, so it all depends on how they get into this space. But then you can think it's like, okay, if there's a global safety net that's taking care of these things, and we have decentralized fractional ownership of access to different shelters around the world, and transportation to get there, it's a different mechanism, because information on the blockchain can't be changed,
Manipulated.
post whatever kind of solution comes out of quantum, because if it just turns into quantum crypto, then that's what blockchain turns into. But whatever that energy stream into the next technological paradigm is, and I think they're going to be happening much quicker. But to think about it in a good way is, can we lift all the work off of our shoulders that we put on to the backs of animals before, that we put onto the backs of machines now in conjunction with humans? Like, can we automate completely the socioeconomic system that exists now, socioeconomy 1.0, with physical and intellectual labor, using AI and humanoid robotics? Can we
if everything becomes automated, does the GDP matter after that? Can you manipulate the GDP based on how many humanoid robots you have out there? I think so. And like, how long does it take to train a human to get to this level of expertise in the workforce? You know, I know we're probably up to the point right now where it can train to be like an entry level service worker at this point, but where was it a year ago? You know, 5 years ago, it couldn't even open a door standing up. So like, there is a trajectory to follow here. And when you converge it with these AIs that have real world understanding, which is very important, is physical AI, not these LLMs, but the ones that can navigate the real world.
I stutter when I'm speaking.
It's like we're going to be able to digitize physical labor, meaning we're going to be able to prompt something, and then something in our physical world is going to change. So that hasn't been able to exist except for labor or volunteering in the past. And now, and besides natural things, of course, and magic things. But
No doubt, magic.
we give a prompt, and then if these things are hooked into supply chains, they can tap into those. But we give a prompt that's like, use the resources that are within our space and create this for us, you know, and then we don't have to do it physically, but it ends up being done anyway. What does that mean for us? What does that mean for
Well, what does it mean for us?
creation? Like, what kind of public works projects can we create together with this kind of power? You know, these kind of things.
Well, I'll tell you this right now. You're going to come up on a big problem. I know you're so strict for the good stuff, but if you add more AI and you add more robots and you add more of those type of labor services and you minus the people out of them, if you do not fix the 40-hour work week to a lower hour work week, you're going to have an absolute disaster on your hand, because you're going to have too many people and not enough jobs, and it's going to be a whole S show. So in some way, the way that we do business would also have to change. So if you take that into account,
I think I'm going to say just now, I think UBI is in full is in play for 2029, and I think it will start before then in the form that what we had for COVID. So it'll be an unemployment benefits for the participatory workforce to begin, and then it'll go out to full.
well, that's going to be a problem, because it's going to be more government. There's, you know, half the people in our country hate more government and half like it. So you're going to have a big problem there, no matter what you do with that.
Well, that's again, and if it's the productivity increases that are happening from the robots, then government's going to change their rhetoric from job to productivity. And then it's like, okay, if that's what's happening, if they're caring more about productivity, then they're caring more about, you know, GDP going up. Pretty much, period. That's what that's going to lead to.
No, I understand, but
they're going to be like, oh, let's ban it. So only a certain amount of robots can be allowed in the workforce, and humans have to be in there. And then other countries aren't going to do that. And some of them are going to be focused on abundance, where it's a race to the bottom, because sustainable abundance is a theme here. So we have to pay attention to that. And deflation could become a thing, you know, if the right energies take hold. So it's like all the problems you can think of literally can be internalized with sustainable abundance. So UBI doing a thing, whether it comes from the government or not, is a necessity, because it's how we're going to buy things. So if the capital gets directly injected into us, rather than through all these different mechanisms like labor or whatnot, that's a different economic paradigm. And it focuses on physics and entropy. So like, how can we control the entropy of this fallout from moving in from one paradigm to the next. And
I do believe we're heading into some
cannot do
big
that.
changes.
We
No, we
cannot
can
do that.
calm down,
Yeah,
bro. You're good. You're good.
humans
You need to
can
calm down. I get your point, but you're really passionate right now, bro.
That's fine.
Is it good?
No,
We're
look,
good.
it's all good. Like, I'm good with it.
Okay.
I just see that there's a few more things that have to happen before we get to that true market that you're talking about, because it's very hard when you have different countries going in different directions and trying to keep the market straight. And when you add all these factors into it, it would be much easier to get all the countries to have the same rules to get the same effect for everybody. When you start changing things, get the currency more correct between all the countries. Now they can't devalue each other like you're saying, because when you get to something that's more AI driven and more taking people out of the equation, if those things aren't in place, we're going for an absolutely hierarchy rule of rich people. And that's not what people like. Absolutely, you will get absolute problems with that without question. And
but
everything that you add more AI into, you must then benefit the worker who does work to make it equal.
No, that's a centralized thought process. There are decentralized platforms where the flows are different. So I need to hear the decentralized offerings like Fetch AI, like AI 16Z, like SPX 6900. I don't hear any of these arguments saying, hey, there's a decentral force out there that can mitigate against these things.
Okay. Well, we're all heading down that same road, whether we go to AI or not. We've
So
been doing
AI,
this for a while.
definitely AI can play a very positive role, because there's a whole group out there trying to use it to increase life expectancy, lower poverty rates, make transportation cheaper for people. So there's a whole force out there trying to create deflation, and it matters.
Okay. Well, I'm just saying, in the end, you still have to deal with the human factor. And no matter how,
Right. But the idea is to obviously take care of the humans, but also all of the forms of life on the planet. And the key factor is to eliminate human error, man, out of these processes.
Okay. Even if in the most efficient system, if you don't have the humans in it, then what's in it for us?
Well, that's what I'm saying is we have to
Explain that, bro.
We have to find new purpose, meaning like if we're not measured by GDP or we're not competing with each other to get to this level in the workforce, what is it going to be? Is it going to be athletics? Is it going to be, because if we're going to try and outsmart each other, that's fine, but it's not going to matter after a certain point, at a level of AI. So I'm like, everything we do has to be measured. In my opinion, it's going to be an aggregate measurement of emotion. And we'll be able to measure that through all these different CCTVs that are about to enter with these robots and cars and whatnot, all the wearables. We'll be able to measure our ability to resonate at a high frequency emotionally, rather than, how much money I'm making, that I have to be a provider, that things aren't abundant anyway, so it's like all these confusion markers in my mind telling people that the old paradigm is like the only way, or like the powers that be is always going to be like that. And I'm like, yeah, it's going to happen, but if sustainable abundance happens also, the richer and richer will keep getting those things, but not at our expense anymore, because we'll be gaining all these access to things we need and the things we want, more and more, with no monetary budget effect, because it's zero marginal cost and exponential economics. So like the clear cut supply and demand economic arguments are falling through with these hyper exponentials. So
let me just go a little further. So we're looking more like a Star Trek economy where everybody works for a greater good. They go into work and they do things. You know what I mean? They join a force to go out to space, stuff like that. But the economics aren't there because you can just make the blankets or you can make the food or you can do all that through other means, right? So is that kind of what you're going towards in the end?
Well, and then another thing is
No rent.
the more and more these AI are using our capital, and the more we give control of our capital to them, there's going to be no profit. We have to consider that. It's existential moment for profit. I don't think anybody realizes that, because it's all going to go into feeding all the, it's like, and then the revenue is just going to match it. So it's based on, it's going to be a complete commoditization of like this entire socioeconomy, but automated.
As soon as AI takes over, different things are going to motivate what runs the companies.
But
Okay.
I'll see. I gotta find that. There's an actual paper I can find for that one.
No, it's fine. I'm just trying to get some outlines of kind of what your channel is. You know what I mean? Kind of gets you to push you to tell a little more. So, like some of these societies, by the way, just so we understand, once you get to that level where everybody's doing what they want to do, they want to be a sculptor, painter, they want to do whatever. There's always a loss that comes in understanding the system that you created. Your generation may understand the system you created, but the next generation knows less, and the next generation after that knows a lot less. Okay, I can work on an old Chevy. Get my kid out there; he has no idea what an old Chevy even is. Do you understand what I'm saying? There's a whole loss factor that goes on in this, and so we're going to lose the basic ability to learn that stuff unless it's trained in you in some way. I'm just saying every society is going to come to that tipping point. So there has to be a human factor to everything and not just AI. And the moral code of everybody's different. So without that one person, one vote in everything that you do, it's going to fail right immediately because we're not going towards a Terminator situation. You know what I mean? We won't go for that as humans. So I mean, there's got to be some social things that are upheld no matter what you do. I hope that makes it into your channel.
Well, yeah, but the other piece is that's up to us. That's not up to us depending on people that really don't know. It's like we have to create this because government isn't moving as quickly as this stuff is. So they're not even close to where they need to be able to come up with these things. So that's why I'm saying it's going to be the DAOs that's going to force the issue, but it has to be through a mechanism where Wall Street can't come in and buy all the governance tokens like they're about to do. So that's where all these DAOs that are going to sprout up from this, because I believe that the idea of decentralization is strong, but Bitcoin is a true decentralized because there's no throat to choke because it's anonymous, but all these other ones have teams and a certain amount of the tokens go to the teams. But there's a person that you can take to court. So there's always a risk of scapegoating in this decentral space as long as there's throats to choke. So my opinion, AI is going to start to build these things for good and bad, and we're going to start to use them as true decentrals, and we'll see where it goes.
Well, you're going to get a Hawk 2 girl in there that ruins everything for everybody. And you're going to have to create certain rules to stop it. And where it's decentralized now, it'll become centralized because of all those kind of problems that go on like that, where somebody builds it up, sells it as soon as it comes on, and then everybody's at a loss. So there's going to be some growth in there that's going to change things from non-centralized to centralized. And they're already starting that in America with the policies they're looking at creating.
Right. And I'm talking about like having the complete opposite of that. So that's like a centralized pathway which people can interact with crypto. without having the risks of all that stuff. So
Okay.
like, the people who create these cryptos have to kind of list all these different things. And there's a majority of the bills out, but there's still like 80% of the bill comes from agriculture because of the commodities piece of it. So the CFTC is going to be all about commodities, and the SEC is all about securities, and then banking and commodity. So it's like the banking committee and the agriculture committee. Oh God, he doesn't hear that. It's just it's so loud. All right.
My bad. My bad.
But what we want is,
Oh, this isn't going to work. I'm sitting here.
so truly, I think we'll be at a point where we can have conversations with our AIs, and then useful applications will be on the other end of that conversation that can help us with one of our issues or solve it. And I think that will be available to all of us.
Okay.
And I think like government services becoming interoperable is a completely doable thing. And I think that, having an application that people can use on their own mobile that would go towards giving instantaneous feedback to different government services through these apps, would be much better use than how we're doing it, because we have like definitely decentralized setup of infrastructure and access, but it's all siloed. So where you go is where you go, and you have to go to this place to get the information, so then you can then take it to this place. So it's not very interoperable. So our entire system is built to remove the systemic issues out of it over time, when we really need to set up like a second layer of Bill of Rights. My opinion.
Papa, are you watching TV?
No, that's it's not TV. I'm gonna get away from there though. That's us.
Oh, okay. One thing I would say, it sounds like you got a pretty interesting channel going on. I would love to see the episode where you get into social security number versus our phone number. You know what I mean? Versus all that stuff where it's like, and I mean that in a way of very simply, you vote on your phone. You know what I mean? Your ideas to your phone, or it's like something implanted in you, something like that. Kind of like a system where it's more easy to access everything, like you were saying, and how you would picture that coming about. That would be an awesome episode to watch.
Yeah, and I will give a little preview on it, and I thank you for that. But I do think that it will be, it'll be a blockchain option. There, people don't want blockchain. You don't have to have blockchain for these types of things to work. But you're definitely going to want, what I was calling them Bitcoin bond accounts before. So the social security number is worthless at this point because it's all been hacked. And, a lot of our personal password data has been hacked. So I think if we had a treasury account, and not necessarily blockchain, but something that's, top line security, maybe even on Bitcoin, because Bitcoin hasn't been gotten yet. And I know we have the quantum argument, but I personally believe that Bitcoin will have its own AI agent, and it will work with quantum computing. So any one actor that wants to use quantum computing to crack Bitcoin, that agent will not allow that. That's what my personal belief is.
Interesting.
So, but but then I also think that would enable the capability of Bitcoin to digitize every single asset that exists currently in socioeconomy 1.0, including physical buildings.
I don't like that. That's gonna be bad. Oh, that's a disaster waiting to happen.
So,
I'll say this, man. I think it's interesting the trajectory of your channel because it's a learning experience for all of us. You know what I mean? How you lay it out, how you say things are going to happen, how what to look for, what to avoid. I think if you have all those aspects in your channel, man, it's going to be awesome.
appreciate you guys. Thank you for the time.
Awesome. That was awesome. Very passionately expressed, bro. He is very into this.
Well, yeah, I'll get more content out there. So we'll get back in it.
Nice.
Thank you.
Yeah, not a problem, man. Thank you for letting us know what's going on, man. I honestly will watch because I'm into all that. I just want to see where the heck everything goes. You know what I mean? What other people's thoughts on it are. Not always doom and gloom.
Yeah. So get some promise.
Wow, something's going on in there, man.
He just keeps walking by me.
It's hissing like crazy.
Yeah.
That was terrible.
All right. I'm actually gonna log out. But thank you guys very, very much.
Thank you for stopping in, man, and telling us everything about your channel. I appreciate it.
And you're getting me motivated to put some content up there, so I will let you know. Thank you. Thank you.
Very nice.
Awesome. Thanks, bro.
Oh, I can hear.
Yeah, it was his the microphone is very sensitive on his phone. I don't know why but yeah.
I think it's an awesome idea that your brother has, to be very honest with you. Some of this stuff just scares the living daylights out of me. You know what I mean? It's so far removed from what we're used to that it's hard to, really see it.
Yeah. I mean, that's definitely, that's what I told him, bro. I'm like, bro, I mean, have you thought of all this? Have you thought of all that? And he's like, yeah, this is a paradigm shift. There are going to be some holes when it happens, and it's scary. That's the main part about it, because
it's like there is a comprehensive understanding.
All right.
Yeah, I agree. It's going to be scary, and there's going to be a lot of shifting going on. I agree.
But with a comprehensive understanding, and channels like my brother's channel and other channels out there talking about the same stuff, it could really enlighten people as to what's going to happen, and buffer that fear a little bit.
There you go. I agree. So interesting, man.
All right. So I during the stream, my Utron, one half of it got finished, and during the conversation, I tried to remove the infill, and it was really loud. I guess I can't hear anything outside of my headphones. So I
understand. We all heard it.
That's not good. People probably didn't want to hear that.
It's all good, Papa. Hey, man. So did it work out? You said while you were taking it apart, something was wrong. Is it going to work out for what you're doing?
Oh yeah, it's going to be just fine. No, everything's working out. Everything thus far has printed just right. I mean, the wall. I mean, it's left very little margin for error, and it's perfect so far.
Nice. You gotta love it when things work out, man.
Yeah, absolutely.
Yeah, dude, I'm excited, man. Between what you and Mike were cooking up, man, it sounded pretty interesting. Like you guys have some crossover ideas, and then I love to see when the Utron coil gets done, man, and how you've configured it. I think that's going to be awesome.
Yeah, I hope everything. I mean, so far it's been seamless, so I hope it just continues that way.
Yeah, some things are just meant to be together, huh?
Yeah, feels like that. So, yeah, man, this has been awesome. Thanks for having me on the show. I really, yeah. So, you did, I don't know. It's been good experience. I did this with, Mike Does once or twice,
Mm-hmm.
and that was, it was a good experience. The second time, I mean, I'm new. So, like I didn't realize that you could just auto like invite people to the stream by sending the link, and all of a sudden people show up, and I was like, "What's going on?" And
Oh
it
yeah,
was like, "How's everybody doing? What's up?" And I don't know. I felt like I got kind of, I don't know what I'm trying to say. Like,
got bombarded by everybody there.
well, and then it kind of pushed out. They all started cross talking, and I didn't have anything to interject. So it was like it just kind of happened naturally. So I kind of like just kind of backed out, like, okay, we'll do this another time. And I guess, it kind of, I don't know, got taken the wrong way maybe because I did lack of communication.
Yeah.
I didn't say.
Well, I'm going to say to you, Papa, you did great today, man. Totally
No, thank
awesome,
you.
man. Yeah,
Thank you.
I like to keep these things to like one or two people when we do these kind of things, so your point gets across.
Yeah.
I think that's very important when it comes to this stuff. I don't like to have a crowd when somebody first walks into it, like, because then it turns into like, water, the water station talk or whatever you want to say it, where
Right.
you all just conversate around the, whatever I'm trying to say. You know what I'm saying? Sit around the campfire with a beer and you all say a bunch of things, but nobody gets their point across of what they're trying to do.
Yeah. Yeah, I'm sorry, man. I like I said, I walked 20 miles in the past 2 days. I'm a little lightheaded. I hope I like held it together.
No, you
Good
did
enough.
great, man. I've been walking a mile, 1 mile, not multiple miles like you, just one. Okay, and it gets me every day.
Yeah. I try to walk a mile purposely a day at least. Yeah, that's good to do that. I think that having at least the lower part of your body moving, if not doing the power walk, is, it'll keep you alive longer.
Oh yeah. Well, because I'll be honest with you, man. The older you get, the more things hurt, the less likely you want to get out there and do it. And then you get into a point where nothing works right anymore. But as soon as you get out there and start walking, then it's like, okay, things are easier. I can get up and do things more, and your body feels better.
Yeah. Yeah. And it's good, man. I mean, especially when you have to, you walk the extra mile, you get that feeling that, you don't get all the time. And it's like, it feels good, it's a release. That's, I don't know, man. It's just good. It's a good feeling. It's like you can actually go to bed and like sleep and not even if you're worrying at 100 miles a minute, you can still pass out because it feels so good.
Yeah, your body's got all the exercise it needed for the day, and then it naturally goes to sleep where normally it doesn't.
Yeah. Yeah.
Well, I'm gonna just plug a few things here, Papa, and then we're gonna hang on and we'll talk backstage in just a minute. Okay.
Yeah.
I just want to give everybody a heads up on Friday at 7:30. we are going to be, myself and Crypto will be on the Traveling Fools channel, and we're going to be doing an update with James. So that big metal sphere that he has, we're going to be talking about that live with him again on Friday night. Also, Mike does his channel on Friday as well. So he will be on from 6 o'clock Pacific Standard Time till about 8 o'clock Pacific Standard Time on his channel, on the Faraday Research channel. And then Joe and I will be here Friday at 2 p.m. Pacific Standard Time to rock out our normal show. So just to let everybody know kind of what's going on, man. So, and then I've been putting Papa Bale's channel in the chat. The little Nightbot here has been dropping it the whole show. So go over and subscribe to Papa Bale. And check out all the cool pulse motor madness he's got rolling around on that channel, man. Doing great work over there.
Thank you. I do have over 3,500 videos and live streams and short videos. And all of them are different. Some of them might look the same, but there's definitely subtle differences in every single video. Yeah, come check it out.
Right on. Papa, hang out with me for a few minutes while I run the credits, man. Everybody have a great day, and thank you very much.
The old man Bill, the old man Bill, the old man Bill, the old man Bill. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality was stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.